Hello everyone, welcome to the series. So today we are going to build Document an enterprise level RAG from scratch. From PDF ingestion to embeddings to semantic caching, everywhere till production level deployment. We'll not only build this, we'll keep on upgrading it with industry level features along the way. So if you're interested in AI, LLM or data engineering, or just interested in building a production ready projects, this is for you. Let's build Document together. So let's start. So what we are going to do over the next few videos is we are going to build Document an enterprise level RAG system. Okay, capable of understanding your documents and answering questions with accurate cited responses. We'll start from the basics and we'll gradually build production ready architecture. So before we get into this project, let me give you an overview. Why do we need RAG? We all know what ChatGPT is. We have all used, okay, it's also a LLM, large language model. So how it works, user asks the question, it goes to the LLM, okay, ChatGPT, and it generates an answer. We all know that it is very good for public data, okay, because as it is trained in public test and generate answer from learned knowledge. But what if you ask questions like, what is a company leave policy, or what is a company termination policy? It might hallucinate, or it may say that it does not have access to the company documents or your private files. Okay, so RAG, Retrieval-Augmented Generation, works. It solves exactly this. Instead of asking the LLM to remember everything, you give it relevant information at query time, and then the system finds the right information from your documents, hands them to the LLM, and then says answer questions using only the information that I provided you. Okay, that's the core idea. Find first and generate second. Let me give you a little brief overview how the core of RAG works, how actually RAG works. So what happens, it's divided into two parts, indexing and querying. Indexing is majorly offline and querying happens online. So let's start. Let's assume you have your PDFs, you have your documents, okay, those are your internal documents policies. So step one is text extraction. Okay, the system extracts the text from each PDF so that the content can be processed by the computer. Next step, chunking. The extracted text is split into small meaningful chunks. Okay, let's assume page 1, chunk 1, page 2, chunk 2, and so on. We do this so that, LLM can efficiently search through hundreds of pages. The next part is embedding, okay, here. So what happened, those chunks are converted into numerical data known as vectors. It's so that the similar stuff can come together and be together and closer mathematically, okay. So then those vectors are stored in a vector database. We will be using Pinecone in this project, and a vector database also stores the metabase of the chunks. For example, the chunks ID, page number, file name. Now comes the second part, that is querying. User asks a question. So a very important thing, the user question is also converted into an embedding. Okay, then comes the next step, that is retrieval. What happens? What it does, it compares the user embeddings with the vector database embeddings, and it retrieves the most relevant chunks from the database. Okay, and then those chunks are forwarded to LLM, which generate answer using retrieve context, and finally you get your answer with your cited source. So this is the functioning of RAG. Okay, so what we have built is exactly on this principle. Document, okay, it is an enterprise document assistant. What it does, it's like a company uploads hundreds of PDFs, okay, HR policy documents. So what it does, it finds the relevant passage and returns a cited answer. Let me show you how it's gonna look. All right, so this is our system. Let me refresh it for you. Right, so what you see, this is the end product that we are going to build throughout the series, and by the end of the series we will have this design output. So this UI is achieved by a Streamlit, Okay, in the left hand side you can see we have we can set our chunking tokens from the UI. Let's suppose I want 250, 350, 400, 500. Let's just set it at 450. These are the overlap tokens. These are the tokens that we have to overlap between different chunks. These are used to maintain the relevancy between chunks. Okay, so and then we have the retrieval, that I want top 2 chunks, top 3 chunks, top 4 chunks to be shown when you are answering my question, right? Then we have upload. Let me upload a PDF for you guys. For computing, it's over for computing. It's not a big PDF, but just for sample, I'm gonna show you guys. Ingest, job submitted. We'll go to the job queue and we'll try to refresh it, and here it is. Okay, it shows you exactly. It had 9 chunks in it, 3 pages, and these many tokens. It's not a big document, it's just for a demo. We come back to the ask and let's ask a question. What is for computing? Very basic one. And here it generates an answer. Okay, for computing is a highly virtualized platform that computes, store, and network services between end devices and traditional cloud computing. So, and as you can see here, these are the sources. These are the cited sources that we were talking about, that it retrieves the chunks. On the basis of these chunks, this answer has been formed, right? Then we come to the eval section, that we can, evaluate our matrices, that how well our system is working, how well our RAG pipeline is working. We'll show you this very cool feature in the upcoming parts. Okay, then we have faithfulness, retrieval, average latency, what are the caching, dashboard. It's a very cool feature for monitoring. You can adjust how many days you want. You want 1 day, you want 14 days, or you want 30 days. Okay, you can even refresh it from here. So it tells you how many calls you have done, how many queries you have done so far, how many tokens we have generated so far, what is the cost that I have used for my API calls this far, what are the queries per day, and the latency on average that I am experiencing. Okay, so it's like you can monitor your system, that how well it is working or how poor it is working. So this is Documine. Okay, that's how it's gonna be. Let's talk about the architecture of this project. System architecture. So what we have done, we didn't build this system as a monolithic system. It's been divided into 4 parts. Okay, 4 phases. So phase 1 is the complete core RAG pipeline, which we have talked here. We can see in the document ingestion part. We upload a PDF, we extract the text, we chunk those text, and then we convert them into embeddings, and then we store those embeddings in a vector database. This is what it is. It's the core RAG system. Okay, as we have seen. So the phase 1 comprises of the core RAG system, and then you've stored into a vector database. User comes, he queries, then the user embeddings and the vector database embeddings are compared, chunks are retrieved, given to an LLM, and answered with a source. Okay, this is what's going to be phase 1. Moving to the phase 2 is production shape. What happens, the problem with phase 1, what we'll encounter is when you submit a large file, so it will block your UI for 30 to 60 seconds. So you cannot go and explore other features of the system like we did right now. So for that thing, we have introduced async injection. That is, we have introduced Redis queue and celery workers. So what's going to happen now, the core working, which is extracting, chunking, embedding, it's all going to happen, but it's going to happen in the background via celery workers. Isn't that cool? So this is what phase 2 is. Okay, now phase 3 is hardening. Okay, it's introducing guardrails and Redis again for semantic cache. What we are going to do, we are going to validate our query. Is the query okay? Is query exposing something private which it should not, some private data? So this is validation, and it is also going to verify the answers. Okay, so what it tells that we have a question, it's get validated, then it comes to a semantic cache. What happens in semantic cache? Let's assume I have already asked a similar question beforehand. Okay, I'm asking what's the leave policy of the company, and somebody comes and asks how many leaves do I get. So these are very similar questions. So what it's gonna do, it's gonna go and it's gonna check its cache, and it sees that there's already an answer provided, so it's straight up gonna give you that answer. Okay, it will not do such lengthy process using resources. It will not deplete your resources again, and it would be faster. But if it's a mess, okay, let's assume I'm asking a completely new question this time. First I asked about the company leave policy, now I'm asking about what is the termination policy. So it's gonna go how it used to work, that query embedding, then retrieve top k chunks and GPT, and then you get the answers. Phase 4, we are going to work in the observability section, okay, which we saw just right now at the end, where we could see how much queries we have per day, how much money we are using up for the queries. So what we have used here is we have used SQLite for logs and metrics, pandas for aggregation function, and Streamlit dashboard finally for the overall UI of the project. So this is how our project's gonna be structured and worked into this. So let me quickly run through what we have done. Okay, so to summarize, what we have covered is RAG as the foundation. Okay, find first, generate second, document as through the line project. We have 4 phases, each wrapping the previous. The query flow, guardrails, it goes to the cache, and then it's get embedded, retrieved, generate, and then you get your answer. The tech stack, we have clearly talked about what we are going to use here, and the final product. It's just not a demo, it's a deployable system with evaluation, observability, and documented decision at every layer. All right, so let's get started.